All right, here we are, and we're dealing with Lesson 5.5, and in Lesson 5.5, we have to correct some of the things that some of your teachers may have taught you before. We've gone through several things as far as knowing what the names of things are. Many of your teachers have told you that that is a square root. Unfortunately, it is the operation of square root, but this is called a radical. Okay, and you have to understand that this will always be called a radical. So when you read it, it's radical. Radical 2, radical 3, radical 4, radical 5, whatever it is. What has changed is understanding that this is the operation is called a square root. Now, vocab. You also have to understand there's something called an index. And an index is located on the outside of the radical. Okay, it's usually right in the front. So if I were to give you a sample one, this would be called the cube root of 8. Notice you don't read it as a square root because it's not a square root. It's a cube root now. Okay. The 3 indicates what your root is. The 8 is called your what?
Base.
Base, correct. Just like over here, 8 is your base. Okay. The 3 is called your exponent. All right. So these are all things that you have to know. They're going to ask you at times to write something in radical form, which means you have to have a radical. They're going to tell you to write things in exponent form, which means you would have to have an exponent. Okay? And you can switch back and forth between these two forms. Okay? Now, the number that is out here is a 3. When there is no number, the understood number is 2. Okay? So it's understood that this is square root when there is no number here. So right now, with your lovely scientific calculator, what you should be doing is trying to find out what the cube root of 3 is, seeing if you can use your calculator correctly, which means you have to find your caret key, or the key that you use to raise to a power. And usually above that key is going to be a different color, and it's going to look like this. It'll have a square root, it'll have a radical sign with an X to the left of it. So what are you supposed to do to be able to put in the cube root? Well, you have to type in what the index is first, then your second function and that key, and then the number. And you hit equal, and it will put it in. So in this case, it would be 3, second function, square root sign, or the caret key, okay, because the square root sign is the second function, and then 8. And on your screen, it should look like this, if you have the correct calculator. Then when you hit equal, it should say the number 2. Okay? Just to double check to make sure you're doing it correctly, now I would like you to do the cube root of negative 125. And as you type it in on your own this time, you should get the answer negative 5. Okay? If you're doing that, then you are correctly working with your calculator. All right, so now we're going to ignore the calculator work. I've taught you how to use your calculator for cube rooting. We're really going to get into the meat of the actual lesson. It's being able to understand exponents and how we're working with exponents. All right, so if I had 10 over 1,000, can anybody tell me how that would be reduced? Yes, you would cross out the zeros and you'd have 1 over 100. Okay. Now, if I had 1 over 1,000, you should notice that that one cannot be reduced. Now, what is the difference? We're going to start writing some of these things as powers. So, for example, 10 could be written as 10 to the first. Anything to raise to the first power is itself. 10 to the third is 1,000. Now the reason we're using the number 10 is because we just have to count the zeros. 10 is the easiest number, and it's the only number that it works this easy with. That the exponent and the number of zeros are the same. It does not happen with other numbers, it only happens with 10. The rule is, when you divide similar bases, when you divide the same base, you subtract the exponents. So when you divide with the same base, you subtract the exponents, which tells me I would do 1 minus 3, which you should know is negative 2. So when I'm dividing with the like base, I subtract exponents, which would lead me to be, if I know when I'm dividing with a like base, I subtract the exponents, you also should be able to write the second rule, where everything is reversed. So when I multiply with a like base, I add exponents. Okay. Now, many of you are wondering, well, when he reduced that, he got 1 over 100, and over here he had 10 to the negative 2. Understanding that these two numbers are the same. Some of you are like, I don't get it. Well, it works like this. Whenever you have a negative exponent, you can make it positive by flipping it over the fraction bar. So it's very similar to what you did when you moved numbers from one side of an equation to the other. You changed the sign when you went over the equal sign. Well, with exponents, it's not going over the equal sign, it's going over the fraction bar. So that means if I were to move 10 to the negative 2 to the bottom of the fraction bar, I would get 10 to the second power, and it becomes positive. Now that doesn't mean we always move it down. It doesn't mean we always move it up. It means wherever the exponent is negative, I move it to the other side of the fraction bar, and it then becomes positive. Okay? That's a rule. It's a rule you can do. It's a rule you can always use. So if they tell you to write it in fraction form, you would have to move it below and write it as 1 over 100. If they said write it in exponent form, then you'd have to write it as 10 to the negative 2. Why? Because in order to write something in exponent form, it must have an exponent. In order to write something in fraction form, you must have a fraction. Okay? That doesn't make the numbers any different. It's just a different way of writing the numbers. No different than if you write 50% as 0.5, and you can write it as 50%. And if I told you to write it as a fraction, you should know you would write it as 1/2. And now you know that if you're going to write it as an exponent, you can write it as 2 to the negative 1. These would all be the same number. And if you want to check that, go ahead and use your calculator with the exponent key and type in 2 to the negative 1, and it should give you the number 1/2. Okay, so that's a way of checking your calculator to make sure you have the right calculator so that you know what you're doing with your calculator. If you type in 2 and raise it to the negative 1 power and hit equal, you should get the number 1/2. All right. So next, understanding how to make an exponent negative or positive. Okay, flipping it up, flipping it down. Being able to understand that all of these are actually the same number. They're just written in different forms. Okay, this one's written as a decimal. Here it's written as a percent. Here it's written as a fraction. Here it's written as an exponent. Okay. Now, what is one of the rules that you have to know with exponents? We talked about this on Friday. I don't really want to go into great depth of how it happens, but anything that's raised to the 0 power is the number 1. Okay? So if I'm going to try and subtract like exponents, or excuse me, if I'm going to try and subtract exponents, I have to have the same base. In order for me to have the same base, whatever was on the bottom would be the same as what I'd have to have up top. So in other words, the number 1 can be represented as 7 to the 0 power, 5 to the 0 power. It's basically like a wild card. You can make it whatever number to the 0 power you need it to be to do your addition or subtraction. It's the only number you can make to that power any way you want. In this case, we're going to use 10 because the bottom's 10. 0 minus 3 is 10 to the negative 3, correct. All right, so now we've gone over why we get how to do division problems. We get when we move something over the fraction bar, we can actually change its sign. Okay, so if we need to write it in fraction form, we can just write it as a fraction. If we need to write it in exponent form, we can put it in an exponent. Okay, so the next thing we're going to deal with is understanding the opposites of cubing to the 4th, to the 5th, to the 6th. They're all called roots. So in this case, this was the cube root. If I raise something to the 4th, what's the opposite of it? It would be the 4th root. Okay? These are opposites of each other. Notice, the tree, we talked about the tree branches being exponential, and then the roots are in the opposite direction, but they also grow exponentially. So you have x to the 4th being the branches, and then 4th root being the opposite. If I said x to the 7th, the opposite would be the 7th root. Okay? So understanding we can go forwards and backwards. It is important. Now, here is something else. When we're writing an exponent form, we now can take a radical from radical form and write it in exponent form. So for example, if I wanted to do 35, the 5th root of 35, if I would like to write that in exponent form, I obviously have to have an exponent. Well, roots are at what part of the tree? Hopefully you know they're at the bottom. So that means if I'm going to make this an exponent and it has to have a bottom, then it will have a top, which tells me my exponent is now going to become a fraction, which means it would be 1/5. So 35 to the 1/5 power is the same as the 5th root of 35. Two different ways of writing the exact same number or numerical answer. And if you put it in your calculator, you'll get the same answer either way. You could do the 5th root of 35, or you can put 35 and raise it to the 1/5 power on your calculator, because it'll do fractions for you, and it'll give you the exact same answer. This is called exponent form. This is called radical form. So let's look at a couple other ones. Let's do a simple one. Most of you know what the square root of 4 is. It's 2. Okay? But if I told you to write the square root of 4 as an exponential form, you would have to write 4 to the 1/2 power. Now, why would it be to the 1/2 power? Because the understood number outside of this radical is 2, and the understood number behind 4 is 1. So the 1 is always on top, and because it's a root, it always goes on the bottom of the fraction. So we'll look at another one. Let's look at the cube root of x to the 9th power. Now this one's a little tricky, because now when we write this one, we write it as a fraction again. Hopefully you understand that that's going to be the root. That's the bottom. So it would be x to the 9/3. And most of you should recognize, wait a minute, Mr. Frazier, that fraction's not reduced. Yes, you must reduce your fraction, and it actually becomes x to the 3rd. Okay? Why? Because you can always reduce your fractions. No matter where they're at, you can always reduce them. And you should always reduce them. This is something that you should get a habit of doing. So we will look at another one. Let's look at the 4th root of x to the 2nd power. So go ahead and do that one real quick. Write it in exponent form. Okay, you should be done. Correct, you should have 2 over 4, and then you should have recognized that that also can be reduced. So it'd be x to the 1/2. All right, so this is being able to change a radical to exponent form, and from exponent form to radical form. Understanding that that's how we go forwards and backwards. Remember, your root is always the bottom. In other words, they're trying to tell you you're going to write your exponent as a fraction. All right? Okie dokie. So now we're going to move on to the last part, and it has to deal with powers being raised to another power. So this is the last rule we learn about. When we raise a power to another power, so x to the 5th over y to the 3rd to the 3rd power. Now notice, where we don't have like bases, so we're not subtracting. Now we have powers being raised to another power. When you raise powers to another power, you multiply exponents. Now I tell people all the time, the little numbers can be multiplied. You can never multiply a little number and a big number. So understanding that this is an exponent and this is an exponent, you can multiply those. Okay? It's an exponent raised to an exponent. It looks very similar to what other operation we've learned about, and hopefully you know that's distribution. Okay? Where you distribute the 3 to what's inside the parentheses. The same thing happens when you're doing exponents. You distribute it to every exponent in the parentheses. So this now becomes x to the 15th over y to the 9th. Okay? Now my marker's fat and bleeds, so it's very hard for me to write the little 9, but it's supposed to be tiny. Okay? It's like x to the 15th. They're supposed to be substantially smaller. They're not the same size as your letters, which some of you do. Unfortunately, that's not what an exponent is. So you need to make sure that you're very decisive and explicit when writing your exponential work. All right, so let's look at another problem. Okay, go ahead and write your answer down. Should take you about 5 seconds, so I'll wait 5 seconds for you to write an answer, and then I'll show you what the correct answer is. All right. So hopefully you remember the rule is when you raise an exponent to an exponent, you distribute the exponent to all the exponents. So that means it becomes 3 to the 7th. Why? Because 3 has an exponent of 1 when it's there by itself. So it's now 3 to the 7th and x to the 35th. What do you think most people miss? They miss the first exponent. And the reason they miss it because you have to understand that it's there when you don't see it. All right. Well, that's it for today's lesson. And if you would, go ahead and make sure you finish your skill practice 5-5. It's due by the end of the period.